Thank you for joining the session. I know I'm in the way of some of you to grab your lunches, so I hope we'll make it exciting. My name is Alan Terleto. I'm the field CTO at Redis. I've been in the in-memory database / NoSQL space for over a decade, and through that time, I've watched the market mature, go through different iterations of hype cycles, and I want to connect a few things for you today that talk directly to the convergence that we're seeing in the data platform market, and tie that into what we're seeing in terms of the new hype cycle around generative AI and how that connects to vector databases. All right, so we'll jump in. So a quick prelude, we all know this, but we're heading towards a digital-first economy. So of course with COVID, some analysts say we accelerated that by about 10 years. And what that means is effectively that really industry agnostic, most of the businesses today, primarily their front door is a digital door. So whether you think about the way you bank today through mobile banking, the way you interact with your retail store, or maybe your kids are still gaming and they're not gaming on consoles anymore, it's these big multiplayer, huge virtual type games. All of it is through digital interactions. Now, if you think about the implications of that onto databases, think about your experience in the store. You go, you try on one shirt, another shirt, maybe you finally make a purchase that takes you 20 minutes, but as a database, there's only one interaction, right? It's the actual transaction of you purchasing that product. Now, apply that experience to the digital, where you might be looking at different products and see people on their commutes, and they could spend a whole hour just kind of going through different product catalogs, and every one of those is a new operation on the database. So the volume has increased through the digital experience onto these kind of legacy databases, right? And it's not just transactions. We talk about the variety, more semi-structured and structured, because we want to leverage that information to be much more proactive about how we engage with that user base. So when we connect that back to kind of the maturation of the database market, and you take a step back and you think about where databases originated, a lot of them, when we talk about mainframes, oracles, they started in about 60, 50 years ago. Sometimes it's important to say that out loud to realize how long ago these databases were created. And listen, these are fantastic technologies. They're not going anywhere. I have a friendly kind of wager between myself and the mainframe about who's going to retire first. And I'm pretty sure it's going to be me. But these technologies were created within a context. They were created at a time where the first principle was about reducing down the storage cost. If you've ever seen photos of what mainframes were back in the day, a lot of that was about the cost of storage. So when they built these databases, they built them with disk in mind. That was the cheapest storage of the time. And they wanted to reduce down the storage ultimately, right? And then they thought about data access. Then they thought about performance. They created SQL as a secondary concern. Now fast forward to the 2000s, when storage costs plummeted, specifically RAM, it became feasible to build what are now called distributed architectures, distributed databases. We were able to leverage much cheaper infrastructure. And with that mental model at the time, we can actually prioritize data access, we can actually prioritize performance. So we can start to build for the way that we want to use or store our data, and we want to build for performance, and then think about storage costs secondary. And that's really where we started seeing a lot of innovation within the database space. And of course, that only got accelerated as we went to the cloud. So what we saw is a lot of categories start to be established in the database market. If you think about MongoDB and why it became very popular, well, right around the time where MongoDB came out, there was a huge shift from XML over to JSON, so JavaScript object notation. And just about everybody was passing JSON into their UIs or within their application layer, and it just was easier, right, to reduce that friction and store that data as JSON as well. Not have to pay the extra transformation penalty of thinking about what that looks like in terms of the columns and rows. And of course, with everyone transitioning to JSON, MongoDB became very popular. Same goes for Redis. Redis uses sets and lists. It's a data structure store. So all those natural ways that we express our data, we use our data, we can actually store our data natively. So it broke what's called that impedance mismatch, which is the way that we store data and the way that we use data. And when we can kind of unify that, we start to see a lot of enablement in terms of performance. And that's what really matters when we talk about the digital experience. Make sure we have that great performance. And of course, event streaming, search, all these other kind of secondary concerns came around because we were able to use more of a semi-structured and unstructured data and be able to take advantage of it for analytics. So we started to see these distributed architectures. But then something happened. in the space. And I'm sure a lot of you noticed it, but I'm going to try to connect some dots if you didn't realize what's happening. With this innovation and with a saturation in the market of these use cases, what came is a lot of competition and also a lot of cheap money. So I'm sure you've heard of this, right? There was low interest rates, a ton of venture capital money went towards these companies. And as these companies went IPO or even before that, there was a ton of pressure, if you're not from the space, on constantly delivering growth, right? 60%, 70%, over 100% growth year over year. And when you saturate the market with the most basic use cases within your silo or category, you start to have to think about what else can we do? So what we saw was a convergence. We started to see these kind of like purpose-built platforms start to do things that overlap into other platforms. So when you see headlines like Confluent, where the CEO was at Kafka Summit, I believe it was 2019, and he said, I see a bit of a missing piece in the database market. We're thinking of data as static. We should be thinking of data as in motion. Confluent will now come out with this KSQLDB, where basically effectively you have an event streaming database. So a logging company, an event streaming company, was then trying to position as a database. At the same time, you saw databases like Cassandra and MongoDB start to position into event streaming market. Right? They're saying, hey, you can use us for data processing. They're actually competing with Apache Flink here, but guess what? Confluent acquired an Apache Flink company. So you see this convergence that's happening. And it's not just those two companies, and it's not just streaming. You saw this with search. We saw this around JSON. You see these around these like use cases, right? And it's not just the NoSQL players, because there's a lot of pressure on Microsoft, who has SQL Server, and all these other companies to continue to drive growth. So if you noticed, ANSI 2023, the spec came out, and it included JSON. But ahead of that was some of these, Postgres included, some of these other relational databases were already supporting JSON. So you see a huge overlap there as well. And of course, I'm from Redis. Redis, we've been ahead of the game when it comes to this for many, many years. So not only were we a multi-kind of data structure store, but what you might not know, and of course synonymous with caching and session stores, but what you might not know is we actually supported for many years already, about a decade, an ability to do secondary in-memory indexing on hashes and JSON. And what that does is allows you to do SQL-like querying. It allows you to do a full text search. We even now support a SQL interface, so if you want to use JDBC or ODBC, you can do that against Redis. That's not something when Redis first came out you were able to do, but of course that overlap happened. And I already mentioned we support JSON. There's also time series and probabilistic filters. So again, doing more with the same platform. Event streaming, Redis is actually known for messaging through its list, but we created a streams API, in addition to triggers, functions, and a seamless way to do data integration. But much more relevant to this topic, and where I'll go from this point on, is our recent, we've been working on this for 2 years already, ability to do what's called vector semantic search or similarity search. You may have heard about this, right? You maybe have heard about it already at the conference. So being able to store vectors, being able to find similar vectors, even doing hybrid searches, so you can do a vector search in addition to scalars or even geospatial indexing. Do things like prompt caching and chat history. So really being able to enable a lot of what you're going to see in generative AI, and I'll touch into what that looks like. So just in case you haven't heard of vectors or vector databases, let's just to level set what's a vector. So we talked a lot about transactional data, or structured data rather, but I didn't touch into semi-structured and unstructured. So when we have data sets around audio and PDFs and video, being able to search on those or search for those or segments of those becomes a huge challenge. We're back to storage costs as a constraint, and the ability to kind of process all that information really becomes a challenge as well. And that's where vector databases really make an impact. So what you can do is you can use a machine learning model to encode that particular modal, or audio, a text, a PDF, and basically shrink it down to a multi-dimensional array of numerics. And what that does is just creates, let's say a 10 gigabyte video into something that's going to be a few kilobytes in a vector database. And then I could apply linear algebra, cosine similarity, some of these advanced machine learning models, to then look for other multi-dimensional arrays that are like the one that I actually just put into my database. So now what I can do is I could take that video, I could take that PDF, I could break it up into what's called chunks. I can convert those chunks in what's called vector embeddings, and I can very quickly, within milliseconds, be able to find other vectors within my vector database and then provide that to you as an output, and then you can translate that back into what you were trying to do. So if you look at the image there, if that gentleman is wearing a shirt and the pants, and I want to just click on the pants, and I was able to chunk out just what the pants look like, then I can look up on the vector database, find just the pants, and then provide metadata where you can go and purchase those pants and anything else that you might want to know, right? That's pretty powerful stuff when you think about it from a retail perspective. So how does this tie into generative AI, right? We got to talk about generative AI at this conference, of course, with the hype. Well, you can do what's called natural language prompt chatting with generative AI. And you can do those using foundational models and LLMs. I'm sure you've heard a lot about that. The thing about it is it's very expensive, especially at scale. I'm doing a panel later on tomorrow, if you're interested. And there's going to be someone from Google, and there's actually a great blog about what it would cost Google to introduce LLMs into their search. And basically, the stock would tank. It's just that operationally expensive to do so. And the reason is not just for training of that data, and not just for encoding that data, but it's the inference cost. Every single time that you actually process that data, there's a cost associated to that GPU, right? And if you think about it, a lot of times it's very wasteful because the questions might be repetitive. So if I ask you this question, and then I ask you this question, and I ask you this question, you pay 3 times. LLMs don't have any kind of memory. So they need a vector database or something to actually store that data and be able to know if they answer that question so they don't have to reprocess. I also might ask you irrelevant questions. So if you're like a wealth or asset management company, and I ask you about aliens, you're going to go ahead and process that, not give a good answer, and it's a waste of everybody's time and money. So we want to avoid that as well. And then there's accuracy. Again, if you're an asset management company and there's a public data set that the LLM is trained on, let's say OpenAI, it's still not enough in terms of credibility to help you service your customers. Because you, and only you, have that institutional knowledge that you've built for 50, 60 years, and you and only you have the information about your particular customers, right? What's their risk profile, what's their portfolio, what their goals are. And you don't want to share that particularly. You can fine tune one of these LLMs, but now it introduces a bit of a security risk, a little data leakage potentially. And it's also very expensive. We talked about the training costs and inferences that it would cost on the GPU in order to fine tune every single time. It also won't keep up because if you're constantly changing your data, then you have to constantly fine tune that LLM model, and that's expensive and that takes time. And it also won't perform well. For example, if you build your own LLM and you want to build an ensemble where you have your own proprietary, every one of those responses is going to be 2-3 seconds. If you ever interacted with ChatGPT, it takes quite a while. So you're not going to build that great user experience. And you might even get hallucinations. So the more, if you ever ask ChatGPT the same question 7 times, you might find that by the 7th time, it actually answers you in a different way. And it starts to kind of make up answers, right? So you want to keep that accuracy, that context. So what can we do about that, and where do vector databases fit in? So this is another kind of big hype term you may have heard, RAG, or Retrieval Augmented Generation. It's really about retrieving that context and providing that context in order to augment the final response that you're going to get back from the LLM, okay? And we talked about some of the ways that Redis can support that in terms of vector search. So I'll walk you through this kind of flow, right? This is actually a little bit more complex in real life. But a person comes in, and let's say it's a chat, and they just put in a prompt. They ask a question. We're going to go ahead and encode that prompt so it becomes a vector embedding. And the first thing we want to do is answer, did we answer this already? We don't want to make the call to the LLM right away. We want to say, did we answer this already, right? For example, I'm from New York, and if I went in a taxi and there was a taxi service and I said, take me to the city, then that person has heard that a lot of times. He knows the answer to that, right? Where's the city? He knows the answer. So within a 97% likelihood, that's how we can make the kind of search criteria. Tell me if I have already answered this question. Now, what if I asked, take me to Manhattan, for those of you that know New York? Is that a different answer than take me to the city? Well, if you're a New Yorker, you know the answer is exactly the same. But a regular database wouldn't. That's why a semantic search can understand the semantics of that question. It knows that city is actually the same thing as Manhattan within the context of New York City. So let's say we have a cache hit, we can avoid the cost of inferencing on the LLM. We saved money, and we responded in sub-milliseconds. That's fantastic. But let's say we did a cache miss. The next thing is, we want to make sure we answer relevant questions. We don't want to do a call to the LLM about aliens. If somebody says, do aliens exist? I don't know, I'm a taxi service. See you later, right? So we want to go ahead and create some guardrails. There's different ways to do that, but one of the ways to do it is through semantic search as well. But let's say the person is asking a relevant question. Well, now we can go to the vector database and say, what are the 3 top or 4 top answers that we have within a certain likelihood, right? So we can use cosine similarity or whatever the algorithm underneath the hood is and retrieve those answers, and also the documents or the embeddings, parts of the documents, that actually contain those answers. And we can then enrich that with any kind of chat history that might have within the session. So if I already asked 3 questions, I can add that as context. And then provide all of that to the LLM with the prompts. So now it'll come with your question, but also all that kind of like footnote or contextual history. And then you can provide that to the LLM. So what just happened? We added potentially proprietary information that didn't need to be fine-tuned within the LLM. So we're going to get a much more accurate response. We made sure that none of the noise came through, so we reduced down the costs. And we also improved the performance, right? We were able to achieve our goal in a very efficient way. So if that makes sense, and you're thinking about like how that applies to your business, the next level will be, okay, well, which vector database is the right one for me? And so it seems like every month, there's a new vector database that comes along. This is, again, we're in the middle of a hype cycle. There's going to be a lot of winners. There's going to be a lot of losers. There's going to be some winners. And ultimately, there's going to be a market established, we assume. So what you're seeing right now is a lot of pure players coming up, and you're seeing a lot of companies like ours integrate or create these features around vector search or semantic search. Again, that convergence is happening, but this time in real time. It didn't take 10 years. It's happening within months. It's pretty amazing. But now, I work with a lot of enterprises. And enterprises, they have to make these hard decisions. You could play around with something if you're a small company. But if you're an enterprise, you have to think about the feasibility cost of bringing in new technology. So what does it take to have does your platform have some kind of disaster recovery capability or active business continuity? Does it operate on Kubernetes, on OpenShift in the same way that it could operate on the cloud? Does it have a managed service if I want to move to that? Does that managed service, can it be controlled through Terraform or whatever my infrastructure as code might be? Does it have integrations across the ecosystem so I don't have to build all that myself? And then, of course, does it have the basic technology or capability so it's fit for purpose for what I need it to do? So these are all the things that enterprises think about it from a technology point of view before they actually go ahead and make that decision. And of course, using a converged database like Redis, which has a decade worth of maturity already built into it and is already used by mission critical Fortune 100 type industries with security and compliance and everything built in, of course, that's a leg up. And then once we get past the technology, we get into the people, which is the real kind of crux of it. So if you're a 10,000 person organization, if you're an enterprise, think about what that means to bring in new technology, right? You have to have developer awareness and skills. What is the cost of training people? What is the cost of onboarding? How hard is it to use? What's the relevant skills in the market? Can I actually hire people to do all this? What does it take for those of you that have been through this process to move through a 3-month vendor management process, right? That's pretty painful. Security, compliance, business continuity, everything I mentioned. And at the same time, there's a macroeconomic, environment that we're in. And all of these companies are looking to rationalize. They're looking to reduce down the amount of vendors that they have. And this is really playing towards the converged data platform market, where we just want to have best in breed. We just want to kind of focus in on a few of these vendors. And we really want to reduce down cost at a time where money's not cheap anymore. And we want to make sure it aligns to our architectural roadmap. So today we're on-prem, we're operating on Kubernetes. Tomorrow we might be in the cloud, we might be hybrid. We don't know exactly where we want to go, so we want to make sure this platform is fit for our architectural roadmap as well. So think about that. If vector databases make sense, you're seeing all this convergence in the market. If this is new to you, I think a lot of these headlines over the next 3-6 months, you're going to be seeing more and more of this convergence happening. You're going to be like, oh, that's what that guy was talking about. And you're going to see a lot of it specifically around AI because there's so much hype going on. So when you think about vector databases, think about everything that it takes to bring it in. And if you want to learn more, because I talk fast, I'm from New York, and I know I'm holding you back from your lunch, there's going to be a couple more sessions by a few great speakers here. So hopefully you guys can check them out. Otherwise, you can find me on LinkedIn or somewhere here in the conference, and I'd love to talk to you. Thank you.